Gravity, or curved space, doesn't always make things fall in. Sometimes objects are in orbit, like the moon around the Earth.
The moon is like a giant marble, okay? But it's actually a ball of rock. Out in space, why doesn't it fall to Earth?
Because it orbits.
That's right, it orbits the Earth, absolutely. But why is it orbiting? Now, Einstein's concept that matter curves space around it also determines how objects move around massive objects like the moon around the Earth, or the Earth around the sun. Okay, let's see what that means, all right? All right, this is space. Now, here's a planet. Here's a planet moving through space. Okay. What kind of a path does it take across there? Is it straight or is it curved? You want to try?
Straight.
Okay, go ahead. Okay. Now let's take a star, like the sun, all right? And let's put it into space over there. Wow. What happens to the fabric of space?
Dips.
It dips, you bet. Now let's move a planet through this area of space.
Wanna
Go ahead. What happens to it now? Is it still going in a straight line?
No, it goes around.
It goes around, absolutely. Okay. Now, can you make it escape from the star and keep on going?
Yeah.
Want to try? Okay, let's see if we can make it escape. Like that. Try again. How fast did we need to try and push this planet to make it get out of there? Faster or slower than to put it into orbit?
Faster.
Well, that's faster, right? Okay. So the Earth orbits the sun because space is curved around the sun. Now, why does the moon orbit the Earth? Because space is curved around Earth, too. Okay? How fast objects move through space due to gravity, and how much space is curved at any point, depends on two things: how much mass the central object has, and your distance from the center of that massive object. Close to the stars, space is curved more than it is out here, where space is curved less, right? Now, if you're far away out here, in this region of space, and you're in orbit, are you going to move faster or slower than when you're in closer?
Slower.
Slower.
Yeah, exactly, right. Let's make the star here the sun. Let this marble represent Mars, and this marble represent Earth, okay? Now, actually, which planet is actually farther away from the sun?
Mars.
Mars, right, exactly. Which one is going to travel faster through space?
Earth.
Very good. How come?
It's
Well-
closer.
Yeah. Where is space curved more?
Closer to the central object.
Exactly. Where the Earth is. Exactly. Okay, so let's try this. Do you see? Let's try that one more time.
Oh.
Okay, you see? Did you see how that was? Do you want to try? Now, how long does it really take the Earth to go around the sun once? How long is our year?
365 days.
Yes, absolutely. Now, Mars only travels about 1.5 times as far around the sun than the Earth does. But Mars has a year that's almost twice as long. Now, why do you suppose that is?
Because it's farther away.
Right, Mars is farther away. And it has a little longer distance to go than Earth. But space is curved less out where Mars is. And you saw that Mars traveled more slowly than the Earth traveled. Exactly, right. So when you're farther away from the center of mass, do you orbit faster or slower?
Slower.
Slower, absolutely.
Notice that if we have a large planet orbiting a small star, the star noticeably moves too. All massive objects exert the force of gravity on their surroundings. This is one way NASA scientists and others detect planets around other stars, detecting the wobble of the star caused by orbiting planets.